Alright, so I'm going to be just doing a couple examples of some things you can calculate using the two compound interest formulas that we talked about earlier. So this first example says, how many years will it take for an initial investment of $10,000 to grow to $25,000? Assume a rate of interest of 6% compounded continuously. So the first thing I look for in any of these problems is what kind of compounding we're looking at, because that will determine the formula that we use. And so I see right away that we're compounding continuously. Well, the formula for continuous compound interest is A equals P times E to the RT. Okay? Sometimes I call that the PERT formula. Alright, so this formula then we talked about in the last video. We can plug in the necessary information because we have everything we need. We have the initial investment, that's your principal, so P is equal to $10,000. The final amount is what it grows to, that's your $25,000. And of course the rate is your 6%, and we always write those as a decimal, so move the decimal twice, it's 0.06. And so the one thing we're looking for is the years. That's all we don't have in the formula, and it's asking for how many years. Okay, so T is unknown. So we plug all the rest of this into the formula. We get 25,000 equals 10,000 times E to the 0.06 T power. Now I'm trying to solve for T. T is up in the exponent. That makes this an exponential equation, type of equation we solved in the last section before moving into the applications here. And so to solve for that, what I need to do is actually isolate the exponential part, which is this e to a power. I have to isolate that portion of the equation, and to do that we're going to use division. We're going to divide out the 10,000 here, right? 10,000 is multiplying that exponential. So we're going to divide both sides of this equation by 10,000. Okay. Now on the right side the 10,000s cancel out. On the left side, I can cross out my zeros on the end here. I get 25 divided by 10. Well, 25 divided by 10 is 2.5. So we have 2.5 equals e to the 0.06 t. Now when we solve this equation, because it's an exponential and the variable is in the exponent, we're going to do the method of taking the log of both sides. Remember this from the last section. To take the log of both sides, I'm going to choose to use a log with a base of e, which is the natural log, because I already have a base of e. So I might as well do it that way. Let's go with the natural log of 2.5. And that is going to equal the natural log of, and make that one a little bigger, e to the 0.06 t. So I'm taking the natural log of both sides. Okay, now when I do that, there's a property, one of our 10 commandments of logarithms, that said if your logarithm and your argument have the same base, then the exponent is the simplified form. And so this simplifies down. Natural log of 2.5 is equal to the natural log and the e drop out, and we're left with 0.06 t. That was using one of our 10 commandments of logarithms. I think it was the 4th I think it was the fourth commandment, or fourth property on our list. Alright, so now if I want to solve for t, all I need to do is divide both sides by 0.06. Of course, they cancel out on the right, and I'm going to be left with t equals, and I got to figure out, I got to calculate this thing. So I'll go to my calculator here real quick, and let's get rid of all that. The natural log of 2.5, close the parenthesis. If you don't close that parenthesis, you're going to get a wrong value. Divide by 0.06. We should get about 15.3 years. Okay, so I round that to the nearest tenth. It's probably fine. Okay, so about 15.3 years. That's how long it's going to take for this $10,000 to become $25,000 at a 6% interest compounding continuously. It's going to take about 15 1/3 years. Okay. Okay. The last example I'm going to do here it's a somewhat similar example, but does have some differences to it. It says, how long does it take for an investment to double in value if it is invested at 8% compounded monthly? Now here I'm actually given less information. I only have the 8%. I don't have an initial principal, I don't have a final amount, I don't have a time. Oh, I do have an end value. Remember I said let's identify what kind of compounding we're dealing with so we can identify the formula. So here we're going to be using the formula A equals P times 1 plus R over N raised to the NT power. Now again, I don't know the P and the A value, but I do know one thing. This double, the idea that the investment will double, all that means is that the final amount is equal to twice the principal. Okay, whatever the principal is. If the principal is $10,000, then the final amount would be $20,000, right? Double that. It doesn't matter. I'm just throwing numbers out there. I do know that the N value is going to be 12 because it's monthly compounding, and that the rate is 0.08 because that is a decimal form of 8%. And so when I plug all this information in, again, P is still unknown, I'm going to get, let's see, 2P equals P times 1 plus 0.08 over 12 raised to the 12t power. Now that's everything I know. Notice the t is still unknown, but so is the p. Now to solve this equation, just like the last example, I've got to divide by the principal because it's multiplying the rest of this stuff. And when I divide by the principal, I'm going to divide the right side by the principal and the left side. It cancels out on the right, and it also cancels out on the left. And so we didn't need to actually know